Hey everyone, let's solve one previous question of TOC. This question was asked in GATE CS 2025 set 2 question number 50. Let sigma equals to 1, 2, 3, 4. For x belongs to sigma star, let 𝑝𝑟𝑜𝑑 x be the product of symbol in x mod 7. We take products of epsilon equals to 1 where epsilon is the null string. For example, product of 1 to 4 equals to 1 multiplied 2 multiplied 4, that is 8 mod 7 equals to 1. Define L equals to x belongs to sigma star, product of x equals to 2. The number of states in a minimum state DFA for L is dash. In this type of question, how many remainder will be, that many state will be. So mod 7, there can be remainder 0, 1, 2, 3, 4, 5, 6. So there can be 7 remainder for state 0, 1, 2, 3, 4, 5, 6. But by production 1, 2, 3, 4, we are not getting remainder 0. 1, 2, multiplication is 2. 2 mod 7, remainder is 2. 1, 3, multiplication is 3. Remainder will be 3. 1, 4, multiplication is 4. Remainder will be 4. Suppose 1, 2, 3, it's 6, remainder will be 6. Suppose all 1, 2, 3, 4. 2 multiplied 3, 6 multiplied 4, 24. 24 divide 7. Remainder will be 3 but not 0. So what we can do, we can remove this 0 state as there are no state having remainder 0. After removal of state 0, there are just 6 states. For remainder 1, 2, 3, 4, 5, 6. So answer will be 6. Now let's create the transaction table for this. We have 6 state Q1, Q2, Q3, Q4, Q5, Q6. Now for input 1, 1 multiplied 1, it will go to state 1. Then for 2, 1 multiplied 2, it will go to 2. 1 multiplied 3, remainder will be 3. 1 multiplied 4, remainder will be 4. Then 2 multiplied 1, remainder will be 2. 2 multiplied 2, remainder will be 4. 2 multiplied 3, 6. 6 divided 7, remainder is 6. 2 multiplied 4, it's 8. 8 divided 7, remainder is 1. Then 3 multiplied 1, remainder is 3. 3 multiplied 2, remainder is 6. 3 multiplied 3, it's 9. 9 divided 7, remainder is 2. 3 multiplied 4, it's 12. 12 divided 7, remainder is 5. Then 4 multiplied 1, remainder is 4. 4 multiplied 2, it's 8. Divide 7, remainder is 1. 4 multiplied 3, it's 12. 12 divided 7, remainder is 5. 4 multiplied 4, 16, remainder is 2. 7 multiplied 2 is 14, remainder is 2. 5 multiplied 1, remainder is 5. 5 multiplied 2, it's 10. 10 divided 7, remainder is 3. 5 multiplied 3, remainder is 1. 15. So 15 divided 7. 7 multiplied to 14, 15 minus 14, it's 1. 5 multiplied 4, it's 20. So remainder is 6. 20 minus 14. Then 6 multiplied 1, remainder is 6. Then 6 multiplied to 12, remainder is 5. 6 multiplied 3, 18. Remainder is 4. 18 minus 14. 6 multiplied 4, it's 24. Remainder is 3. 24 minus 21, it's 3. So total we need 6 states for this DFA. I already discussed similar type of question during lecture. Just go through the lecture, and if this lecture is helpful for you, please like, share and subscribe. Thank you. Bye bye.